Hey everyone, in today's lesson I'd like to share some info on the project that I had recently, and the idea was there is a big worm crawling under the ground, and while moving the ground was breaking, and so we had some bigger chunks, smaller chunks, and some dust effect. I also was given a reference, which was the Rebel Ways groundbreaking effect, which is a great one to learn from. But the difficulty for me was actually to implement the setup into my scenario because, first of all, it was a very detailed setup, so it took me a while actually. To test and to try actually to implement into my scene. Um, Another one was the irregular ground shape, and it was quite big map to work with. Another thing was that worm was moving not on one axis; it was moving diagonally. So it also had some problem with orientation, especially with the detail setup. So I had to actually go my way, and let me actually show how I made it. So there is a try of actually using the Rebel Ways method. So I actually had to do it a little bit differently. So here's the my setup. So here I have a proxy worm geometry and the landscape, and as you see it's quite big. For example, I just and also it was low poly, so you had to kind of cut this out. And also when you have uh, like comments from your client, you have to tweak it very fast, and like simulation time should also be faster. So yeah, it worked pretty well in that case. So what I did, I convert all the geometry, the animated and landscape into regular geometry. Then what I did, I extracted some uh, uh, the head of that worm to use it as a reference, as a guide. So I did a time shift in the beginning and in the end. So I had two geometries. Um, this is my direction. Okay. Then I created sort of a bound and cut this geometry out from here. I have a uh, uh, rough cut of the geometry, which where is the worm is moving in this area. So I'm trying to reduce the polygon size. So here I'm cutting it once, then I'm fusing the geometry, the static head geometry, and then I'm um, creating a line with the normals as a direction. And here I'm um, uh, exceeding. I mean, I'm creating. I'm pushing my vertices to elongate the lines in both directions. And uh, how I'm doing it, I'm actually multiplying my normal and adding to the position. This way you can extend extend the line. Then I'm adding some up vector in case I'll need it. So this later I'm using it as the attribute transfer, this carving, but here I'm doing the same operation. Okay, here I have the same setup. I could actually simply use like this there. Oh, maybe it's slightly longer. Yeah, it's let me keep it as it is for now, but you can check it afterwards. I will upload these files for you just to check out the setup. So here I'm using this line. I'm adding a sweep node and transforming it so I can extract once again to lower the area that I will work on later. Okay, and here I'm doing some additional setup. This is the cutter object. So this piece will be broken into pieces. Now, this is the area where the worm is crawling, and here I'm reversing it. I'm adding some noise just for having some irregular shape, and then I'm cutting this out from that final ground piece. And here I'm doing some setups for the rest of the ground that I will use as a collision geometry. So I tried a few methods. So I tried to convert that into VDB, but later the method that worked for me was converting it to the basic packed RBD geometry. So I cut it into pieces by using some scatter points and Werner fracture. This way, when you use it in your simulation setup, it's very convenient because you will use it as a simple convex geometry but not concave, which actually I had problems using it. So mainly you would probably use some basic geometry or convex, I think convex method of using just simple geometry. Okay, so here's my ground that I will use in my simulation. The next method, here I'm actually using the ground itself later as the small collision geometry. So it will be used later on during the simulation. So here what I'm doing, so I'm having this piece of geometry that should be broken, and here I'm breaking it into pieces. What I'm mainly doing here, I'm adding in the rest attribute, and then I'm adding some noise to give it more irregular shape, and then I'm fracturing it, and then I'm using the rest attribute, to have my points being placed as it was before. Okay. This way I'm creating some just I add an exploded view. Okay. So here, so here you see as the chunks are irregular, and if I just turn off the noise, you see that I have some flat cuts, which doesn't look real in this case. Okay. Next here, I'm doing some extrusions, and I'm using for each method to add some color to my pieces, and then I convert them to detail as a detail attribute, then back detail to primitive attribute, and I'm creating the scale attribute by using the color. Okay, and then in the poly extrude, I'm using the descale attribute as an extrusion multiplier. This way I can get some pieces bigger or smaller in the depth. Okay, then here I'm having let me turn this back. Okay, so adding some normals and packing my geometry for the simulation. Okay, so here's the line that I created before here, and I'm using it as the attribute transfer to activate my simulation. And here's my packed geometry that I'm converting to points, and I'm giving it black color, and here I'm using the attribute transfer to transfer my active geometry, which is Y. And here I'm also adding some orientation, spinning values. Okay. Here I'm transferring some normals, actually creating some normals by subtracting that 1 point, which is Y, to those original points that that represent our fractured geometry. Okay, and if I just turn on my normals, you see there is normals, and they just look outwards this way. I will use normals as the velocity, so I could just push my fracture geometry upwards. Here I'm also using the color to affect my orient attribute, and then I'm converting my normals into velocity with the multiplier. From here, there is another a process that I'm creating here smaller pieces, smaller chunks of geometry, and the method, actually the older process that I've explained before, is this. It goes the same as in creating a smaller chunks. So as you see, the method is quite simple. I could even make a shorter, smaller setup actually, to because as you've seen, there is a lot of repetitions taking place in this setup, because I usually work like I come to a certain setup while testing everything and making a lot of setups, and then after I get the needed result and optimization is done with all necessary speed and like procedural setup, which uh, which actually is the goal, and then afterwards just for the sake of not forgetting, uh, I'm doing a cleanup work. Okay, it took a while, but the process is the same. Just as you see, we have by using this uh, rest attribute and noise values, we create those smaller chunks, which really helps and look very organic. Okay. Here I'm adding some extrusions, and I place it actually under the bigger chunks, if I'm not mistaken. Yeah, so you see, so adding normals, assembling, giving a name attribute, and then packing it into uh, pack primitives. So here I'm also using the attribute transfer method to give some value to smaller chunks. The same noise, normals, and orientation or spinning values, and then converting it to the speed. Okay, and the next part is the uh, dynamics itself. So there's a ground, there's a gravity, and here's the um, it's like I can also actually delete this, but I kept it for just for the sake of maybe there's some smaller chunks will fall, so they could stop and do not affect my simulation time. Okay, so here's the actual ground that I okay that I've imported, and I'm using the separate solver because here I'm using a subsolver and I don't want to affect this simulation, this setup. So here I have bigger chunks, okay, the first context geometry, and the secondary smaller chunks as the secondary context geometry. And in the subsolver, I'm using my V1 attribute that I've created for the smaller chunks actually, which actually gave me that effect that I needed. Okay, and I'm transferring my CD, velocity, and um, orientation attributes, and here I'm converting by using the color. So if the color is greater than 0.1, so the pieces are active. Okay, coloring it back. And let's see. And so here's the result of the setup. So, and if I look from the camera, I render this one. Yeah, and this setup was very flexible in this case. Okay, you see, you could simply add some forces and get some immediate results. And also, if, for example, the director would like to extend the camera and animation of this monster character, you could easily actually simply uh, adding some time shifting and extend your simulation without any problems. Okay, so here I am I'm extracting the pieces and adding a transform pieces attribute by using name. Okay, and adding some color just visually. And also I avoid um, this self-collision effect, so I don't think that it's visible in this case. So the smaller chunks mainly contact with the rest ground. Okay. Next, I have merge them together just to see the dynamics. And here comes the smoke dynamics part. So here I'm extracting, because I'm still having those pieces packed, and I'm using the length of the velocity by some value if it's smaller than this value, so I remove the points. So as you see, I have those bigger points as an activator of smoke dynamics. Okay, here I'm unpacking the geometry, and then I'm converting it to a source, some attributes, velocity, density, and temperature, and then um, uh, I simply add the collision, that ground that you that that we saw before, and the main setup is to have some dissipation value and cooling rate, and also I did a negative buoyancy, so because of its sand, so it could just fall fast in a fast way, fall faster. Okay, and some turbulence and disturbance and shredding, so the smoke could dissipate faster. Okay, and some pyroback volume to give it some visual look. This is the final merge of the setup. Okay, well, as you see, what is great about Houdini is there is a ton of ways actually to achieve one type of effect or different type of effect, and there is a small setup, some bigger setups, which one is convenient to you. So I'd like to share my own way or version of doing it, and well, and yes, that is all that I want to say. I hope I hope the information was useful and you liked the tutorial. And yeah, thank you for your attention. If if there is some interest in all those lessons that I'm doing, please subscribe. I would really appreciate it. And yeah, thank you very much and goodbye.